So I received lots of nice comments about this wind turbine powered and solar powered Meshcore node that I built and designed, and I was just gonna swap out one of the pieces for one that's slightly better. That's this nose cone. So I thought I would actually take the whole thing to bits and give a brief overview of how it works. So the design of it is a little bit convoluted to dismantle because it involves taking off this nose cone first, but I'll just do it, and I'll probably speed up the footage as I do it. So step one is dismantle the nose cone. Each of the blades are printed separately and vertically on the build plate, but they've got a wee overhang, so there's 2 screws each per blade. I'll show you when I get one of the blades off. Really, this screwdriver is not quite long enough actually, but each blade has a screw that goes into its neighbouring blade. So you can see here, there's a screw there that goes into this blade and a screw here that goes into that blade, and they're all around this central hub, which allows the hole for the axle to be printed vertically, which gives it a wee bit of a easier to tolerance around a shaft, and also stronger as well when you put a shaft into it, so that the shaft doesn't force any of the layers apart. And the shaft is retained by a wee pin that you'll see in a minute. So this will begin to fall to pieces. Thankfully, you'll need to take one of the blades off to remove the whole assembly. So that's that off. That screw needs to come out. So there's one of the blades. It's printed flat on the build plate here, like that. So all prints without any supports. Unfortunately, on my printer, the bed temperature fluctuates. I've tried dialing it in, but it still fluctuates enough to cause this rippling at the top end as the bed changes temperature. The shape changes, and that wobbles it ever so slightly as it expands and contracts. But I think it'll still be acceptably aerodynamic, at least for the purposes of this thing. So the main shaft in here has this, again, all printed without supports, this wee notch that locates into a matching groove on the blades, and that just keeps them retained, and then when you tighten them all up it clamps onto this, and then it doesn't go anywhere. And this is held on to the shaft. There's a wee pin that goes through it. I'll just see if I can find something to push that out with. I have a bit of wire here somewhere. Maybe this will do it. Now I can stab myself even harder. There we go. So you see there's just a wee pin that retains that onto a 4mm shaft with a 1.5mm cross drilled hole. Can you see that? Just about. So that goes there, but I'll not lose that pin actually. Just put that. And then that's now safe to take this cap off. So this cap is comprised of 2 pieces. There's one single screw under there that holds the whole lot together. This is the piece I need to replace, and I'll show you why in a second. So you just take that screw out. These are all self-tapping plastic screws. You know, the sort of the thickly pitched ones that cut themselves into plastic. The reason I'm replacing this is I realized that actually the water, because none of it's got a hard water seal on it, it's all just gravity based sealing. So if any rain comes through the antenna hole, it will go into here, and in theory it should run out of that hole there, but I realized that if it makes it onto this, it might go this way. So this new one has a wee slope there. so that if any water makes it in there, that slope will just direct it back down towards the hole. There shouldn't be water coming up from underneath it because it'll just be out in the rain, so that can go in the bin. And then, once you've got it to this state, this whole electronics assembly just pushes right out. It's on wee rails, like that. And then this is into here's plugged the solar panel. I'll just take that out. So this thing is the nacelle. It's got the solar panel on top. That's glued in with watertight silicon, and then it's just got a wee cable with I forget the type of connector. Maybe I'll put it on screen if I remember. The connector that goes into the solar panel socket of the rack 19007, is it? This number of this board? It's a rack 4630, the chip, but I think the board, when the chip is on the board, it becomes 19007, I think. Also, the chip itself is 4630, but when it's on its subboard, it becomes 4631. It's confusing. It took me a while. Anyway, so this is the unit itself. This is the actual, the guts of the machine. So anyone who knows about Meshcore or what's the other one? Meshtastic will know probably what this is. This is the bit that's new to me. I just built this for a bit of fun. So how it works is, where to start? Yeah, so this board takes power in from a solar panel to charge batteries. So this is two 18650 cells in parallel, so it's just matching the voltage. It does the same as one cell, and that goes into here. And then here is where the solar power comes in. So what I'm doing is I'm supplementing the solar panel, the wee emergency solar panel on the top, with wind power from the turbine. So over here is the distribution board for the power. So out of there comes the power that goes to the board. That's 5 volts. And into here goes the solar panel and the turbine. All this is it's 2 diodes from the 2 positive leads stopping the power from one going to the other. So it's stopping the power, or the power coming out of the turbine from going into the positive of the solar panel, and stopping the positive from the solar panel going into the output of the turbine. It's like a check valve for water. I don't really know how diodes, I know how they work, but I don't have that electronics intuition to do it all properly. So I'm just thinking of them as check valves here. Okay, so you all know how solar panels work. I'll follow this lead. It goes through this wee hole and uses up some cable and comes to this. This is the charge regulation board. I don't know what exactly I'd call it. I don't have a name for it. But what this does is it takes 3-phase AC, which is what comes out of the brushless. It's a brushless motor. I think it must be from a CD player or something. Essentially, it's a brushless motor, but in this case, it's being used as a generator. So when you turn that shaft, it generates. And it generates 3-phase AC. So those are the 3 phases there. And what you want out is 5 volts DC. So this board, some of it's under there. I just put that on there because it saves a bit of space. So what this board does is it rectifies the AC coming out of the motor, and also boosts it. It boosts the voltage, because without that you only get like 1 or 2 volts out of this at low RPM. This takes that, and through some kind of electronic magic, I won't claim to know precisely how it works. I ran the simulation on a circuit simulation website before I built it, and it seemed to do what it was advertising. I found a circuit diagram that I basically followed, and I'll put that on screen so that you can see how that works. It does something. It takes the low voltage input, chucks it through a bunch of capacitors and boosts it, and then outputs higher voltage DC. So this boosts maybe like 2 or 3 volts, maybe to like up to, I think it was up to 18 volts when it's going fast. And then also on this board there's a think it's a Zener diode, and that regulates the voltage in the output. So when the voltage here, which is these two pins here, are the voltage generated by the DC of the board, this smaller board is an off-the-shelf voltage regulator that changes 12 volts DC to 5 volts. But when the voltage multiplied by this board exceeds, I think it was 18 volts or 16 volts or something, what the Zener diode does is that has a reverse breakdown voltage, and when it exceeds the reverse breakdown voltage, it basically goes dead short. So this thing will generate voltage, it will rectify it up to the point where that voltage is too much for this step-down board to handle, and then it'll just dead short it. And that will dump all the power through the Zener diode, which should be able to handle it. I mean, it's not a big turbine, it's not going to be generating kilowatts, so that will heat up, and the turbine will be braked by that power going through there until it slows down again, and then it'll start feeding the voltage back in. So it's not a very high-tech system, but it should, in theory, be relatively reliable. One thing I would like to change is not have that Zener diode doing that breakdown regulation. Basically what it means is if it runs too fast, if the wind is too strong, it will stop generating because it goes dead short. So at the moment I don't know what wind speed it takes to cause that to happen, because I only put this up the other day, but so that's how that works more or less. As I said, the circuit diagram, I'll try and remember to add that. This is just an AliExpress board. This I soldered myself from, it uses 3 components. So it uses these capacitors, it uses these diodes, and then it uses this Schottky diode, and I used these diodes again to do this board. So you don't need a vast wealth of varied components to build that circuit. The brushless motor has a 2mm shaft and then a wee connector. That could probably be better off being a universal joint, because when I was assembling it, when you tighten these screws, there's a bearing under here and here, and when you tighten these, sometimes the shaft will not quite align due to the pressure of the screws one way or the other, and then it'll lock it up a wee bit. So if that was a UJ, a universal joint, that would probably make it run smoother. But for now, I'm just going to leave it as is, because I cautiously tightened, it's got a grub screw on each side, cautiously tightened one screw after the other until everything lined up. But the motor, or the generator, that has to be very low kV rating. A kV rating is the number of RPMs per volt that you get out of a brushless motor, I think that's how it goes. So the lower that is, the more volts you get per RPM from your generator. You can generally identify it by the fineness of the windings. You probably can't see it in there, but there's windings. The thinner those windings are, the more volts you'll get out of it per RPM when you're turning it. This motor I found on AliExpress. It was listed as a sort of science toy. It came with a wee LED, and the idea is that you put the LED into the cables and then you spin the motor and the LED lights up. But in this case, it's been put to far better use here, and that's basically it. So the standard rack cables, LoRa and Bluetooth. Have I got these the right way around? I hope so. Yes. Well, that's good. I accidentally took these antenna off at one point while it was powered up, and then I didn't know if I put them back on the right side, but that looks good. Other features, so this, as you saw, it slid out on a track. So this board has, in the nacelle, it's got a wee, I don't know if you can see that, there's a track that goes all the way along, so it just slides in. It's a bit tricky to get the turbine shaft to line up with the hole when you put it back in. So I've actually changed the design of that. Now it's got a chamfer, so it should locate by itself rather than what I was having to do is stick a scalpel in the end and wiggle it around until it went in. This is just a galvanized nail. Here there's a drain hole, so somewhere inside, you won't be able to see it because it's all black, but somewhere inside there's a hole that goes up through. That's just in case any water makes it in there, it can drain out. It's not any good if it sits at an angle like that with the nose downwards, which it might do anyway because the whole thing is nose heavy. But I don't think the water level would get to any of the electronics before it started to run out that hole. Additionally, there's this slot here, so as the shaft comes through, there's a wee channel at 45 degrees, so any water that makes it in there should run off out of there as well. It's a downwind turbine, so the wind should be going that way, and that's why it has this big vane. The vane also is for printing it, so it goes in the build plate that way. That helps to stabilize the print. And then the turbine blades, rather counterintuitively, because most big turbines you see the wind comes from the front, but these ones, the leading edge is actually this edge here. You can see it, well, it's easier to feel, but you can see the aerofoil is optimized for that. It does mean the blades are in the lee of the aerials and the tower, but it still seems to work. So that's more or less it, yeah. It's not a complicated thing. I'm not an electronics engineer, so there's probably lots wrong with it in terms of electronic design, and also it hasn't been running for very long, so I can't say how it will perform in the long run. But if anybody wants to replicate it, then feel free. I'll post in the video description the names of these components and maybe the dimensions of the bearings and things if I can remember, and links to things. But other than that, yeah, I hope that's useful, and I'll go and put it back together just now. Let's see. And then we take the new one. And that's more or less it. Thanks for watching. Hope it's helping.